Here we'll have a look at 2011, question 1, part A. This is a nice little question for a certain type of question. We'll explain what it is along the way. So what do we know? Well, we have a particle falling down. So I often like to draw out these diagrams, even if they're not fully necessary, just to process the information in my head as I go through it. So we have these points A, B, and C. It starts from rest, u equals 0. That's quite important. And then, of course, acceleration is gravity. We'll talk about the signs in a moment. And the time over here, so it reaches B after time t, and it comes down further 2t over 7, coming down here. All right. B to C is a distance of 2.45 meters. Okay, and we're not given any information about this one, so we'll just call that h. Right. And we want to find t. Okay, so these are our bits and pieces. Now, a little note on the signs. Okay, strictly speaking, g is a force going down. So g is normally it's a negative. Acceleration is minus g. In this case, all of these are displacements. So these displacements would be going down. So that would be a displacement of minus 2.45. Now, because it's a fairly straightforward question, all kind of happening in one dimension, we're going to set down as positive. We don't always do this, but I'll do it now, which means g is positive, h is positive, 2.45 is positive. Just makes math a little bit cleaner. Okay, but if you're wondering why we do that, that's what's going on there. Now what I'm seeing is falling down through these multiple stages and information about these stages. This is a common initial velocity question. All right, that's the thing to remember. And when we do these guys, it's really, really crucial that we lay out our stages correctly. So this is a lovely example of that, but the key is to figure out that that's what's going on. Because in stage 1, okay, we are going to go from A to B. That's fairly straightforward. But in stage 2, this is the one you need to be careful on. Okay, it's not B to C because we don't know anything about u there. We don't know the velocity at this point. We also don't know the velocity at the end of it. There's too many unknowns. So instead, stage 2 is A to C. Get that right, and the rest is just algebra. Now, let's see what we know. Now, if you know what you're doing on this one, you may know which equation to go with, but again, let's always assume we don't. Vu, A, S, and T are the 5 variables we deal with in linear velocity. All right. Do we know anything about the final velocity in any of these stages? No, we don't. Do we know anything about the initial velocity? Yes, it's 0. Acceleration is gravity. S, yeah, we have information about these. I'm not going to write them all out, but we know them. And times, we have lots of information about times. So that means these are the 4 that I have information about. So therefore, I'm going to use S equals ut plus a half at squared. If you want to list all the other equations out, you'll see v equals u plus at, v squared equals u squared plus 2as. You should know these. Both of these are velocity. Okay, and each of these 3 is only missing one of them. There's no time here, there's no displacement there. And that's how we choose which one to use. So no harm, good practice, write it out here. Let's tell everybody what you're using. Also, as you're getting used to this in the initial stages, it means you're not going to make a little slip on substituting it. Okay, so let's start laying it all out. Well, AB, displacement is h. Okay, 0t plus a half gt squared. So h equals gt squared all over 2. Okay, that one's fairly handy. What about A to C? Well, the displacement is h plus 2.45. And that equals, so u is 0. And the time, so these two, add them up together and you're going to get 9 over 7. 9 over 7t plus a half g 9 over 7t all to be squared. I would recommend write them out kind of clearly like this. If you ever have to go back and debug it and check it, and sometimes you'll know what it's going to be at the end, show it's equal to something, you can follow this very easily and pick up a slip. Like an often slip here is we say the t squared is 9 over 7t squared, and we forget to square these guys. You'll see it easily with this. Again, I'm writing the u in as 0 in case I just put it in as ut and wonder how do I get rid of it. All right, h plus 2.45. All of these guys are little systems that make life a bit easier. So g over 2, and again, I'm going to separate these one and do them in 2 stages because 81t squared over 49 is quite easy to do, but if I'm starting to multiply by 2, mistakes happen. So we end up saying h plus 2.45 equals 81 gt squared all over 98. Right, equation 1, equation 2. Now, at this stage, if we have two equations, how many unknowns? I've got a h and I have a t. Those are only my two unknowns. Remember, we know g is 9.8. So it's not an unknown, even though it's a letter. Where do we go? Well, we go with simultaneous or substitution. Now, I have probably a slight fondness for simultaneous equations, but in this case, it's so easy, we'll just do substitution. So we'll sub in for h. So therefore, gt squared all over 2, all right, plus 2.45 equals 81 gt squared over 98. Now this is looking kind of nice. Okay, we can begin to see how this might work out. Now let's see what we can do. There's a few ways you can go at on this one. Now, at this stage, you can crank it out in your calculator, but I would begin to look for little patterns. Look at this. What's g? 9.8. And what's this guy here? 98. So we have something going on. Now, I want to deal with this first, so I won't do it yet. 2.45. Okay. Well, double it, you'll get 4.9. That might ring a bell. Double that again, you get 9.8. So this is actually g over 4. Now, don't worry if you don't spot that. It does make the maths easier if you do, but it's not the end of the world. Your calculator is very good at this. So let's assume you don't spot it. We'll bring it over this side. 2.45, okay, because again, I want to get all my similar stuff on one side. So all my gt squareds, I'll put them over here. I'll break them up into 81 over 98 minus 1 over 2. Okay, now you may spot that that's going to be 49 over 98 if it's a half, and 81 minus 49, you can do that, or we can just punch it in the calculator. So 2.45 equals gt squared by, we'll do it in the calculator because I always assume you don't know it, and not in a bad way, 81 over 98, because in an exam, this is where you make really silly mistakes, so I would actually even use a calculator in an exam. 16 over 49, okay, 16 over 49. Now, I am actually going to call that 32 over 98. Why? Well, remember we said, I see the g here, so that is going to be 2.45 equals t squared of 32 over 10. A little bit easier to work with. All right, well, let's sort it out. Let's send these guys over here. I'm going to reverse them because I like to my t-squares on the left because I'm just weirdly obsessive like that. And that is 24.5 over 32. Don't freak out about putting decimals in here. It's no big deal. Again, you may work with that. You may notice, of course, it is 49 over 64. You don't need to see that because you can just say, you know, 24.5 over 32 equals, and it'll tell us. Okay, what are we seeing here? Squares. Yes, happy days. So t squared is 49 over 72. So therefore the square root of 49 over 72, you'll probably know this, of course, over 64, helps if you get the maths right, is 7 over 8. So t 7 over 8 seconds. And there we have it.